May 6, 1937. A massive aircraft slowly appears in the evening sky above New Jersey. Passengers look down from the windows, expecting a smooth landing. Below, a crowd gathers to watch the arrival of one of the largest flying machines ever built, the Hindenburg, a symbol of technological progress. A giant airship capable of crossing the Atlantic Ocean in just days. For years, it represented the future of air travel. Elegant, quiet, luxurious. But on this day, something goes terribly wrong. As the aircraft prepares to land, a sudden flash appears near the tail. Within seconds, fire begins spreading across the surface. Then everything changes. Flames consume the airship rapidly. The structure collapses in less than a minute. Passengers and crew struggle to escape. The disaster unfolds in front of cameras and witnesses. Shock spreads across the world, because this tragedy was captured on film, and the terrifying images would change aviation forever. Tonight, we examine the design, the warning signs, and the critical moment that turned a technological marvel into one of the most famous disasters in history. Because sometimes, progress moves faster than safety, and when it does, the consequences can be catastrophic. During the early 20th century, air travel was still evolving. Airplanes existed, but long-distance travel was limited. Crossing the Atlantic Ocean was difficult and dangerous. Engineers began exploring another solution: airships, large floating aircraft supported by lifting gas. Unlike airplanes, airships could travel long distances smoothly. They offered stability and comfort. Passengers could walk inside spacious cabins. Large windows allowed views of the ocean far below. Dining rooms served hot meals. The Hindenburg became the most advanced airship of its time. Stretching over 245 meters long, it was longer than 3 football fields. Inside, passengers experienced luxury rarely seen in aviation. Private cabins, observation decks, elegant interiors. For many, traveling on the Hindenburg felt like stepping into the future. But hidden behind the beauty was a serious risk. The airship relied on hydrogen gas for lift. Hydrogen is extremely flammable. Even a small spark can ignite it instantly. Some experts preferred helium, a safer alternative. But helium supplies were limited at the time, so hydrogen continued to be used. Despite known risks, in May 1937, the Hindenburg begins another transatlantic journey. Departing from Germany, the aircraft travels toward the United States. On board are 97 people. Passengers include business travelers, families, and crew members. The flight progresses normally. Weather conditions near landing are unstable. Strong winds and storms affect the schedule. The airship circles the landing area, waiting for safer conditions. Hours later, weather improves. The Hindenburg prepares for landing in Lakehurst, New Jersey. Ground crews move into position. Ropes are prepared to guide the airship safely to the landing mast. Spectators gather to witness the arrival. Airships were still rare, and the Hindenburg was the most impressive of them all. Everything appears normal, until 7:25 p.m. Witnesses notice a small flame near the rear of the aircraft. Within seconds, fire spreads rapidly across the surface. Hydrogen ignites instantly. Flames move faster than anyone expects. The airship begins collapsing. Passengers attempt to escape. Crew members act quickly to assist. But the fire spreads too fast. In less than 40 seconds, the aircraft is destroyed. A technological symbol disappears in flames. The disaster shocks the world. News footage captures the tragedy. Radio broadcasters describe the scene in real time. The emotional reactions spread globally. People witness the disaster through newspapers and cinema newsreels. The visual impact is powerful. A massive flying machine destroyed in seconds. Questions immediately arise. What caused the fire? Investigators begin examining possible explanations. Hydrogen ignition, electrical sparks, static electricity buildup, structural material flammability. All possibilities are analyzed. Some experts believe a gas leak may have allowed hydrogen to escape. Others suspect weather conditions contributed to static discharge. Hydrogen burns quickly and intensely. Once ignition occurs, stopping the fire becomes nearly impossible. The disaster highlights the dangers of flammable lifting gases and forces engineers to reconsider airship safety. Investigators analyze physical evidence and witness testimony. Multiple theories emerge, but one conclusion becomes widely accepted. Hydrogen played a major role in the rapid spread of fire. Hydrogen itself is not explosive without oxygen. But once exposed to air, it becomes extremely dangerous. The outer skin of the airship may also have contributed to the spread of flames. At the time, aircraft materials were still evolving. Fire resistance standards were limited. Safety testing was less advanced than today. The disaster forces aviation authorities to reconsider risk management. Airship travel begins losing public trust. Passenger demand declines rapidly. Airplanes soon replace airships for long-distance travel. Faster, safer, more practical. The era of passenger airships begins to end. The Hindenburg disaster becomes one of the most well-known aviation tragedies in history, not because it was the deadliest, but because it was seen, photographed, recorded, witnessed by millions. The visual evidence left a lasting impression. Technology promises progress, but progress requires caution. Engineering decisions influence human lives. Material choices matter. Risk evaluation matters. Testing matters. Safety margins matter. Because even small design vulnerabilities can create catastrophic consequences. The Hindenburg disaster reminds us that innovation without safety can lead to tragedy. Today, aviation engineering follows much stricter safety standards. Materials undergo extensive testing. Design approvals require verification. Lessons learned from past disasters influence modern engineering. Because every disaster leaves behind data, every failure leaves behind knowledge, and every event becomes part of the archive, a permanent record of what happened. So future mistakes can be prevented. Because history does not only tell stories, provides warnings, and sometimes, warnings arrive too late.